This is introduction to our physics classroom. So you are in physics and you need to know certain level of math. So before we start, I know you've all been in math. Some of you like math, some of you don't like math. And before we start physics, I usually spend at least a week in the classroom to go over the math that you need to know. So for in physics, we're going to be using a metric system. And the measurements are going to be, like, the distance is going to be in meters, not in miles. The time is going to be in seconds. The mass is going to be in kilogram. The weight is going to be not in pounds, but in newtons. You don't have to memorize anything yet. You just have to know that we're going to be using a metric system. You can see this information online in our PDF lessons. And the links are added to your lessons in the Google Classroom. And you will have to know the prefixes and how to use them. Some of them you will see often, others you will hardly ever see. But it's good to know that you recognize them and know where to look for them. So let's say if you want to say in metric system, everything goes by tens. So if you have, let's say, deca, you could rewrite 20 as 2dA, and dA will mean deca, and deca means 10 to the first. If you had 200, I could use hecta. So if I had 200, hecta stands for 10 to the second, so that is 2 hecta. So H stands 10 to the second. I will know that that is 2 10 to the second, or 200. If I had 2,000, so instead of writing 2,000, I could use kilo and write it as 2 kilo, and wherever I'm measuring that in, like kilometers or kilo miles and so on. And if I have mega, it's 10 to the 6. So instead of writing 2 million, I can write 2 mega, and that will stand for 10 to the 6. If I have 2 billion, which is 9 zeros, right? So if I have 2 billion, instead of writing such a big number, I can write 2 giga, and that stands 10 to the 9th. And this is for larger numbers. If you have smaller numbers, you would use something that converts the prefixes that convert into smaller numbers. So let's say if I have 0.2 of something, then I could write 2 deci. So deci will stand for 10 to the negative 1. So if I had not 0.2 but 2 hundredths, so if I had 2 hundredths instead, I could use centi, which is 2 centi to 10 to the negative 2, milli 10 to the negative 3, and so on. So we're going to use prefixes a lot. Sometimes information is going to be given with a prefix and you have to convert it. So that is something that you need to know, and we're going to do some practice so you feel a little bit more comfortable about it. So let's look at some basic mathematics that you need to know for the class before we start even physics. So this is just a video of introduction to math that you need for regular physics classroom. So I want to convert these numbers to scientific notation. So I have this number and I have to convert it to scientific notation. Scientific notation means I have a one-digit number, decimal point, and there are some numbers afterwards. So I'm going to convert 0.07882 into, and I'm going to round it, into scientific notation. So I'm going to do 7.9. I'm rounding 88 into 9. What I did, I moved this decimal to the right. So I wrote the number that is bigger than my original number. That is wrong, because this number is not equal to that number. This number is much smaller than the one that I wrote. So I have to specify it and write 10 to the power, and to make it smaller than it is, I have to write a negative power to move the decimal back to the left 2 positions. So that will give me 7.9, 10 to the negative 2. And because I know what my prefixes mean, centi means 10 to the negative 2. So I'm going to rewrite, let's say all of these are in meters. So in meters, instead of like in miles, you write I. If you measure something in meters, you write M as meters. So there can be a little bit confusion here. Milli is M and meters is M, but meters is like measurements. I can measure something in pencils, I can measure something in hands, in feet, and so on. So M is just a measurement, meters, but milli is a prefix. So in this case, it's measured in meters, but the prefix is centi, negative 2. So I can write my answer as 7.9, and instead of negative 2, I'm going to write centi, and it's measured wherever I'm measuring in meters. Maybe I have a ruler, like the ruler like right here, that measures in metric ruler. So it's centimeters. So the answer for 1 in scientific notation is going to be 7.9 centimeters. Let's look at another example. I'm going to choose number 3. So I need to write this number in scientific notation. Again, I start with a digit number, and then wherever it comes afterwards is going to be after the decimal. So it looks like it's going to be 1, and then 18. And then I'm going to write 10 to what power. But before I write 10 to some power, I want to see what I did to my number. I had a big number, but I made it smaller. So to go back to the original number, the one that I had, I need 10 to the positive power, because I want to move this decimal to the right to make this number again big as it used to be. So I move this many positions back. So my decimal jumped this many positions back. Now I have to put it back all the way till the end. So I have to move 1, 2, 3, 4, 5 positions. So that is 10 to the 5th. I don't have the prefixes 10 to the 5th, so I'm just going to leave it this way. So it is 1.18, or if you wanted to round it, it's going to be 1.2, 10 to the 5th. And we decided all of these numbers are going to be in meters, so I'm just going to write M as meters. Let's look at the one number. So here is number 5. And you can always write me an email and ask with some solutions to the problems that you see here online in our lessons, and ask me if you did it right, so I can respond to you if you're doing the questions correctly or not. So I have this number, and I have to write it as scientific notation. Scientific notation, again, starts with the number, and then the decimal point, and then wherever comes after that. So I'm going to put the decimal right here. So that is 2. And I'm going to round the rest of the problem to 8. So I have 2.8. I placed the decimal after 2. So I moved 1, 2, 3, 4, 5 positions. So I know it's going to be 10 to the 5th. Now I just have to think about whether it is 10 to the positive 5th or 10 to the negative 5th. So if I look at my questions here, my question right here, I made my number bigger. I made the number 2.8, which is bigger than my original number. So I have to make it smaller. When I write my number, I have to specify this is not as big number as it actually was. This number must be smaller than the one that I wrote. So in that, because of that, I have to write the negative sign. So that means if I place the decimal after 2, I have to go 1, 2, 3, 4, 5 position back to get to the original position for my decimal. So that negative number will tell me that I have to go back. Here's some questions that are given in scientific notation and you want to rewrite them in standard notation. So I'm going to choose just some random questions. So here is number 14, and I'm going to move my decimal to the right 6 times. So I have 1, then I have 5, 2, 5, and I need 3 more zeros. So I needed to move 1, 2, 3, and then again 1, 2, 3 gives me those zeros. And I'm measuring everything in meters, so my answer is in meters. I could also rewrite this number as 1.525 measured in meters, but instead of all this, because I placed the decimal right here, instead of writing 10 to the 6, I could use the prefix, and 10 to the 6 means mega, so I could rewrite this number as well, 1.525 mega meters. But they didn't ask me to write it in with the correct prefix. They just said rewrite in standard format. So the standard format is going to be 1,525,000 meters. I'm going to solve one more question from this section. So I'm going to choose with a negative power. So let's do number 16. This one says I have to move my decimal 4 positions to the left. So if I have a 5 and I move the decimal 1, 2, 3, 4, so I have a 0 point and I have 1, 2, 3, 5 is the 4th position, and 1, 8, 2, 1. So the answer is this much. And let's say I'm measuring it in meters. So this would be my answer. I'm going to skip the rest of them because I think converting back to standard format is probably pretty easy for you. What's interesting that there's only 3 countries in the world that don't use metric system, and the United States is one of them. So you see the red spots on the map. These are the only countries that don't use metric system, and so we're one of them. And I think United States tries to go away from imperial system to metric system. Okay, let's look at some more questions here that we have to check. So write in scientific notation again. So I'm going to just choose one random number. I'm going to do this one. I know scientific notation is one number and then whatever comes afterwards. So I'm going to place the decimal right here. I have 6, 0, 3, 10. My number is bigger. The one that I wrote is bigger than the one that I used to have. So I need to make a negative to tell me that the actual number is smaller than what I wrote. And I have to go back 1, 2, 3, 4, 5, 6, 7. And let's say we're still making measurements in meters. Let's look at the questions how we multiply 2 numbers written in scientific notation. So if I have, let's say, number 41, I'm going to show you this example. I have 2a to the 3rd times 4a to the 6th. If you remember, the answer would be 2 times 4. And then how many a's do I have? I have 3 a's here, and I have 6a over here. So how many a's do I have in total? So there is 9 a's. So that is 8a to the 9th. The same happens when I deal with the numbers with scientific notation. I multiply their numbers, so the answer is going to be 8. And then the power is going to be 10 to the 9th. So if I do this question, I'm going to do exactly the same. I'm going to multiply my numbers, so 6.7 times 2. It's the same as 6 plus 0.7 times 2. That is 12, and this is 1.4. So that is 13.4, and the power is -3 and -5, so I have -8. Here's one more question I'm going to look through in this section. I have 1.7 times 2. So it's 1 times 2 and 0.7 times 2. gives me 2, and 0.7 times 2 is 1.4, so that is 3.4, and 5 and the negative 5 gives you 10 to the power of 0, and anything to the power of 0 is 1, so that is just 3.4 as my answer. So when I had multiplication, that was pretty easy because I had the same powers for my two numbers, scientific notation numbers. So if I do have the same powers with them, it's the same as having 2a to the third plus 4.7a to the third. So addition is a little bit different. It's not the same as we did with multiplication. What this says is I have 2 of these types of apples, maybe on a different alien planet, and I have 4.7 apples, the same apples. So how many of those apples do I have? I have 6.7 of those apples. I don't change my apples. I keep them the way they were. So let's say if I have this question, number 48, I have 2.6, 10 to the 5th. These are one type of apples, but these are different types of apples. I cannot just add them and say this is how many apples, which ones do I have, to the 5th or to the 4th. So I have to convert them. So I'm going to say this is 0.28, 10 to the 5th. So I converted the second number, 10 to the 5th. How do I check if I did it right? So if I look at this number, I made it to the 5th. Because if I take 1 away from here and it's a positive 1, then my decimal is going to move back to where it used to be, and it's going to be 2.8, 10 to the 4th. So I always will check. If I change my powers in one of the numbers, I always will have to check. So here I have same power now, so it's the same type of apples now. So I see it's 2.6 plus 0.28 gives me 0.88, 2.88, 10 to the 5th power. And at home I'm trying to practice, but there's only 4 questions that I see online that I can practice. So maybe I'm going to make my own questions. I'm going to make 1.2 10 to the negative 3 plus 2.5 10 to the negative 4. You see, they're different. These are not the questions that were given, but I can always make my own questions. So in this question, again, I don't have the same power for them. And because I don't have the same power for them, I need to make them the same power. So I'm going to take this negative this way, and there's only going to be negative 3 left. If I take the negative this way, the negative number will move my decimal to the left. So I have 0.25, and here I have 1.2, 10 to the negative 3. Now I can add them because they're the same. So my answer is 0.45, and I don't change my apples. I just say how many apples I have. So that is 10 to the negative 3 types of apples. So here I made my own questions, and I already solved it. Always try to pause and solve the questions, especially if you're watching the video. So I'm going to do maybe number 49 right now. So it's okay to pause it and try to solve it and see if you got it right. So for number 49, I notice again that they are different powers over here. So again, I'm going to take one negative and change this number. That negative will move my decimal to the left. So I have 2.2, 10 to the negative 27 plus 0.76, 10 to the negative 27, because I took one of the negatives away. So that gives me 296, 10 to the negative 27. So for number 64, different type of question. I'm going to rewrite it. I'm going to do 2 questions. There's one question on the top, and then I have to do the division. So at first, I'm going to do the top, the numerator. So I'm going to rewrite 0.6 and 0.4. And then because they're multiplied, I just have to add their powers. So that gives me 10 to the negative 7. And then I have 0.2 in the denominator and 10 to the negative 6. So I can see that they can be cancelled negative 6 from top and the bottom. So what's left on the top is only negative 1. Also, I see that 0.4 divided by 0.2 is 2. And then what's left on the top is 0.6. Because 2 times 2 gives me 0.4. So 0.4 divided by 2 is 2. And on the bottom, in the denominator, I have nothing left. So my answer is 1.2, 10 to the negative 1. Let's try to do another question similar to the one that we just did. So again, in number 65, I have 1.2 and 2.4. So there are different ways to solve this question. But as long as we're following the same kind of rules, then it's easier to simplify. Negative 4 and negative 3 will give me negative 7. And on the bottom, in the denominator, I have 0.3 and negative 2. So I'm going to cancel a negative 2 and the negative 2 from the top and bottom. So that gives me 10 to the negative 5 left in the numerator. And then I see I have 1.2 on the top and I have 0.3 on the bottom. So I'm looking at this part, 1.2 and 0.3. So I could do times by 10 and times by 10 top to bottom. So that gives me 12 over 3, which is 4. So I can write 4. And what's left is, that I didn't touch yet, 2.4. There's nothing left at the bottom because I cancel all my denominator, so that is 1. And 4 times 2.4. So 4 times 2 and 0.4. I do 2 times 4 is 8. And I multiply 0.4 times 4 is 1.6. So my answer is 9.6, 10 to the negative 5th. I'm skipping some questions. I'm not solving every single question that we have in our lesson, but I'm just showing you examples. So here is another one. I want to convert 5.67 centimeters into meters. So at first, I'm going to think what centimeters are. And you can have that table in front of you if you're doing the lessons for practices. So centi means 10 to the negative 2. So I can rewrite this number as 567. Instead of centi, I'm going to write negative 2 and meters. And what I want to do is to convert this number into meters alone. So this negative 2 will move my decimal to the left 2 positions. So I have 0.0567 meters. And let's look at the next example. It's 12.3 centimeters. So I'm gonna rewrite this question as 12.3. Instead of centi, I'm gonna write 10 to the negative 2 meters. I want to write my answers just in meters. So my negative 2 will move the decimal 2 positions to the left and will be left with meters because I'm not going to have centi anymore. I already used it. So that's going to be 0.123 meters. So here's another example. I have decimeters, not decameters. Deci means negative 1. So I have 567. Deci means negative 1 meters, and I want to write it just in meters. So I'm going to use this negative 1 to move my decimal to 1 position to the left. That gives me 0.567 meters. Here is an interesting question. It's 5.67 kilo. Kilo stands for 10 to the negative, for 10 to the positive 3. And what I want to have is 10 to the negative 3 meters, right? So I see meters here, so I could write meters, But this part, kilo, is positive 3, and milli is negative 3. So here is a little trick. Between the number, so here I have the number 567. So between the number and meters, I need to have a 3. So on the other side, between the number and the meters, I need to have 3. But what I have is negative 3. I have to cancel that negative 3 somehow. So what I'm going to do is to write 10 to the 6. Because 6 and the negative 3 will give me the original 3 that I used to have. So my answer for this question is 567, 10 to the 6. And instead of negative 3, it's actually millimeters. And I could rewrite this answer as 5 and move the decimal 6 position. That's going to be 6, 7, 0, and then 1, 2, 3 zeros, millimeters. Let's look at another example. Again, I have in 11, I have 12.3 kilo. Kilo is 10 to the 3rd meters. And I want to write something 10 to the negative 2 meters. So between the number and the meters, I have 3. So between the number and the meters, I have to keep my positive 3. But what I have is negative 2. So how do I cancel that negative 2? I'm going to add a 5. 5 minus 2 will give me a original positive 3. So I can rewrite this answer as 12.3, 10 to the 5th centimeters. Centi stands for negative 2. So if I have negative 2 centimeters. And I could rewrite this number as 12, move the decimal 5 positions to the right, gives me 40 centimeters. So that would be your number. Let's look at this question as well. So I have 567 nano, negative 9 meters. And on the other side, I want to have milli, negative 3 meters. So again, between the number and meters, I need to have negative 9. So between the number and meters, I need negative 9. So I'm going to write 567. And I have to change this wherever is in the green box. So if I do negative 6 and negative 3 will give me negative 9. So my final answer is 567. And this part is millimeters, so that is millimeters. And here I have negative 6, because negative 6 and milli gives me negative 9, and this is what I used to have, negative 9. And then I just have to move the decimal 6 positions to the left. So I have 1, 2, 3, 4, 5, 6, and then 6, 7 millimeters. So that will be my final answer here. Here's another example that I want to solve in this video. There's going to be a few more that come in related to kinematics before we start dynamics and all other videos. So this is the first one where I'm only introducing you to math. There's going to be one more video where you have more math, and then after that we're going to start kinematics. So in this one, I have 16 kilometers to convert into meters per second. So I have 18 kilo. Kilo stands for 1,000, so it's 18 kilometers. And per hour, so instead of hour, I can write 3,600 seconds. So in 1 hour, there's 3,600 seconds. And I need to convert in meters per second. Well, I already did meters per second. So I can divide both top and bottom by 100. And then I can divide top and bottom by 18. So what's left on the top is 10, and on the bottom is 2. So my answer is 5 meters per second. And I will do the same for number 72. Try to do it and pause the video. So you see I have 72 meters over 3600 seconds, which is hour. I'm dividing the top and bottom by 100 and then by 36. So if I divide by 36, I get 20 and 1, so that is 20 meters per second.